Hello, I'm Mr. Bob, and welcome to my Algebra 1 video series. This video covers Chapter 7, Section 1, titled Solving Systems by Graphing. By the end of this video, you will have reviewed methods for solving systems of equations by graphing. This will be followed by analyzing special types of systems. You will review systems with no solution or systems with infinitely many solutions. You'll also get a look at a real-world problem. Please subscribe to this channel if you find it to be helpful. So before we get started with this review, I'd like to go over a couple of definitions. So systems of linear equations. Two or more linear equations together form a system of linear equations. You could have 3, 4, 5 different linear equations, but if they're all packaged together, that becomes a system. Solution of a system of linear equations. Any ordered pair in a system that makes all the equations true is the solution of the system of linear equations. No solution. A system of linear equations has no solution when the graphs of the equation are parallel. If the lines don't cross, you can't have a solution. It's where the lines cross is the solution for a linear system. And if you have, as we were speaking of many linear equations, you could have 5, 6 of them, but if they all cross at the same point, that point is the solution of every one of those equations. Infinite many solutions. A system of linear equations has infinitely many solutions when the graphs of the equations are the same line. So if they're on top of each other on the graph, right, you could have 1,000 lines. If you could only see one because they're all on top of each other, that's where we get the infinitely many solutions. Okay, objective 1, solving systems by graphing. Two or more linear equations together form a system of linear equations. One way to solve a system of linear equations is by graphing each equation. Look for any point common to all the lines. That's what I was saying before. If you had 5 lines on a graph and they all crossed each other and at the same point on the graph, that would be the solution for that system. Any ordered pair in a system that makes all the equations true is the solution of that system of linear equations. Okay, example 1, solving a system of equations. So our system here we see here are two equations, y equals 2x minus 3 and y equals x minus 1. So what are we going to do? It's just solve by graphing. So here we go. We're going to graph both equations right here. Graph both equations, okay, on the same coordinate plane. This is what we've done over on the right. Y is equal to 2x minus 3. Well, how do we graph it? The easy way is you look for the slope. What is the slope? The slope is 2. That means rise of 2, run of 1, both in the positive directions. Okay, so or it would look like 2 over 1, right? And then it says negative 3 is the y-intercept. We know that because this is slope-intercept form of the line. So we go here to minus 3. We're going to go right here. Here's the negative 3 down in the bottom on the left. Okay, and we're going to go to plot it. We're going to go up 2. The rise is 2, and we're going to run 1 to the right. Up 2, run 1, and you see right here we got a dot here. A little blue line crosses right there, right? So let's look at it. The slope of y equals x minus 1. The slope is 1, right? So you 1, and the intercept, the y-intercept is negative 1. So we go right here, negative 1. It's the y-intercept. And the rise is 1, and the run is 1. Rise is 1, run is 1. Look at that. They land at the same spot. So the solution is right here. 2, 2, comma 1. X of 2, y 1. That's the solution to our equation. So let's take a look at what they say. Find the point of intersection. You did that. It's 2, comma 1. Check and see if 2, comma 1 makes both equations true. Now this is it. Now you're going to find out what does that mean to make them the same, right? To answer both, right? That's what you want to have. It has to be both have to be true at this point. So if we look at y equals 2x minus 3, that's our first equation right here. And we substitute in y equals 1, because our y1 is y is 1, and x is 2. And then in the equation here, we're going to substitute in right here 2 for the x, and then we're going to solve it. What are we going to get? We're going to get 1. Is 1 equal to 2 times 2, 4, okay, minus 3. 4 minus 3 is 1. Well, guess what? There's the solution. 1 is 1. So it's definitely a solution for that equation. Let's look at the next one. Y equals x minus 1. Well, now again, we're going to substitute 1 for y right here. We're going to put a 1 in for y, and we're going to put 2 in for the x. And so we can look now. Is 1 equal to 2 minus 1? 2 minus 1. Yes, 1 is equal to 1. So this is the solution. 2x of 2, y of 1 is the solution to this system. Both of these equations are true at this point. So, okay, example 1, check your understanding. So if you know my videos, you know I want you to pause here and try these two systems on your own. And when you come back, we'll work them together. I'll wait for you. Okay, I assume that you've done that and you've had good success. Let's try it. I'm going to draw you. As you know, if you've been with me on these before, my drawings aren't all that great, but let's try it. So I'm going to start with drawing a graph because you know what we do, right? We put these on a graph and solve them. So this is our x and this is our y. This is negative x, negative y. Okay. Let's start with 1, 2, 3, 4, 5. Let's do 1 here. Let's go negative 1, negative 2, negative 3, negative 4, positive 1, positive 2, 3, and 4. Okay, it's a bit of a graph. I'm basing this on the numbers I see here. Let's see, 1, uh, 4, forgot these. Okay, so now let's do the first equation. I'm going to change this to red. And I'm going to say the red equation right here. What is the slope? The slope is 1. And you know that 1 is really 1 over 1, right? And you know that the upper number is the rise and the lower number is the run. So rise is y, run is x, okay? So the slope is 1, and we know the y-intercept is plus 5. So we're going to go up 5. 1, 2, 3, 4. Here's the y-intercept. I've got a dot. So now I need to plot at least one more so I can create a line, right? So what does it say? The slope is up 1 over 1, up 1 over 1, up 1 to the right 1. I can go down, do the same thing of keeping it down. I can go down 1, which is the opposite of up 1, and then over 1, meaning to the left. So I can do that, down 1, over 1, down 1, over 1. So now you see the line is something like that, okay? That's the red line. Now let's do a blue one. The blue one, here's blue. The slope is negative 4 and the y-intercept is 0. So when x is 0, y is 0. So here's that y-intercept. And now we're negative 4. Okay, so that means negative 4 over 1. So the rise is a fall, right? So it's a decrease in 4 and then to the right 1. Okay, so what we're doing now is we're going down 4, 1, right from here, from 0, 1, 2, 3, down 4, and to the right 1. Well, our other line is way above this, so maybe we should go the other way. So now instead of going down 4 and to the right 1, we're going to go up 4, the opposite of each. 1, 2, 3, 4, and to the right, to the left 1. So and here you see the line we created, right? So the line is right here. Pretty good. Okay. Where do they intersect? Well, they appear to intersect at negative 1 and 1, 2, 3. Um, well, I guess I think I was supposed to draw a little higher on that because I'm supposed to be 4, right? 1, 2, 3, 4. I'm at 3.5. So I should have done that. Let me erase this line a little bit. My goodness, Bob. Let's do that and get that out of there, okay? So let's start over on the blue. So the blue says we're going to go up 4. 1, 2, 3, up here and over 1. I had it in the wrong spot. And now draw the line. Same line. It'd be a little straighter. Okay. And the other line started here and went down 1 over 1. Down 1 over 1. Down 1. Oh, down 1 over 1. This is it right here. Down 1 over 1. Down 1 over 1. So the line would be, the red line would be something like this. And here's the spot right here where they intersect. And if you look at that, it's 1, 2, 3, 4 up and 1 to the left. So I'm going to say it's -1, 4 is the dot, that is the point that intersects. So what we have to prove is, does that work? If we put in a 4 for y and take 5 and subtract 1 from it, for our x value is -1. So I'm going to write it, y is equal to -1 plus 5. And I'll say y is equal to 4. Okay. Then I should rewrite that. Take the y and make it right here. How's this? So now 4, is 4 equal to -1 plus 5? The answer is yes, 4 equals 4. And how about for the other equation? -4x plus 0, right? So we put in the same values. So we're going to take y is equal to 4. Does that equal to -4? Excuse me, does that equal to, okay, -4 times -1. And if you solve it, you get 4 equals 4 times 1 is 4. Negative times negative is positive. So yes, they're the same, 4 and 4. Okay, hope that worked out for you. We're going to do the next one here in just a second here. Okay, let's look at problem B. Again, we're going to graph, right? We're going to graph each of these. So I'm going to start off, I'm going to switch back to gold like I did on the other one. I'm going to draw the graph, do the best I can on that. Okay, and I'm going to say 1, 2, 3, 4. Let's do 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so we're going to graph here's y, and here's x, -y, and -x. The first equation says our slope is -1/2. I'm going to change colors. I'll do red again. -1/2, and our y-intercept is 2. So we're going to start at 2, y-intercept of 2, and it's a half. But is it going to go up and up 1 over 1? No, it's negative, right? So it's got to go down 1 over to the right 1, okay, to here. And it's got to go down 1 over 1 to the right, over, down 1, excuse me, please, I'm not thinking correctly here. Down, get rid of the red, that's, oops. Get hang the line back in here. Okay, so now we're going to start at 2. We're going to go down 1 over 2. Excuse me, down 1 over 2. That's what it says. Down -1, down 1 to the right 2, or it also means up 1, back to the left 2, up 1, back to the left 2. And if you draw that line, I should have drawn this in a different color, but It's about like that, pretty close. Now I'm going to change the line. So now we're going to get this. It says that the intercept is -3. 1, 2, 3. Oh, thought I had red. Or blue, rather. 1, 2, 3. Okay. This one here, we're going to do 1, 2, 3. Okay. And then it says the slope is -3, which means what? -3/1. Or it could be 3/-1. So let's think of when you're going to go the opposite direction. So in order to go the opposite direction, we want to aim toward this line. So we're going to start here at -3. We have to go up to intersect the other line, right? We have to kind of go in that direction. And it's negative. It's a negative slope, so it's going down the same as this. This one here is, they're both negative, so they're both going down. This one's going to go up at kind of an angle more steeply. So we're -3. So we're going to go up 3 and to the 1, 2, 3, and then we're going to go to the left. At this point, we're going to go 1, right? So 1, 2, 3, and 1. They're not quite meeting. I guess I did this. See, this dot should have been a little higher. This one here should have been higher. The line would have been higher. So we're going to pretend that these are both this dot here. So now when you look at this is -1 and 1, 2, 3. So we're saying -1, comma 3 is the point where they intersect. And if I draw that line, so this one was going to go from here, -3 over 1. Oh, no, oh wait, see, I'm getting confused on the dots. This is up 3, 1, 2, 3 over 1, up 3, 1, 2, 3 over 1. It's this dot. This is where the blue dot is, right there. Excuse me. The blue dot was not at this point. Okay, so now we're going to draw that blue line in there. So now the blue dot is over here, and the line's going down here. So we got this line right down. This one's going to go to here. So I'm going to go, let's see if I can get them. It's about like that. And this yellow one, the gold one, went through, yeah, more like that. Now we've got the point. I want to put this red. Here's our point right there. And that point is not -1. Excuse me, everyone. I know that's pretty confusing. It's -2, 3. -2, 3. And how do we check it? So now we're going to go down in here, and I'll use, I guess we're on blue now. I'll stay with the blue. So we're going to say, I'll do it in red. The red equation is y equals -1/2 x plus 2. And over here, I'm going to say that the blue equation is y equals -3x minus 3. Okay, we're going to solve both of these with this -2, 3. So I'm going to put y equals 3. Y equals 3 equals -1/2 times -2 plus 2. 3 equals negative. A negative is a positive. A half times 2 is 1. So 1 plus 2 is 3. 3 equals 3. And when I do the blue equation, I'm going to put in the same thing. I'm going to put 3 equals -3 times 2, or -2 rather, times -2 minus 3. And what is 3 times -2? It's 3 equals 6 minus 3 equals 3. Okay, so 3 equals 3 in both cases. Sorry for the confusions on that, but when you're freehanding these and you don't have rulers, and These are always good to do with a ruler, a nice straight edge, so that you can draw nice straight lines. And when you're doing them by eye like this, they get a little cockeyed, so to speak. Okay, hopefully you made it through. Watch it again if it's problematic on the second one, but I think you'll be okay. Okay, example 2 is a real world problem. Let's see what it turns out to be. Suppose you are testing 2 fertilizers on bamboo plants A and B, which are growing under identical conditions. So that would mean like the same soil, same amount of water each day, the same amount of sunlight. That's kind of what they mean by that, right? Okay. Plant A is 6 centimeters tall and is growing at a rate. So let's 6 centimeters tall and growing at a rate of 4 centimeters per day. Plant B is 10 centimeters tall and is growing at a rate of 2 centimeters per day. So this is plant B is growing slower, but it's starting off taller. After how many days will the bamboo plants be the same height? And we're going to solve that by drawing 2 lines and seeing where they intersect. What will their height be? Okay, so what do we do? Let's define D as the number of days that they're going to grow. And f of D, or remember the y term, right? F of D is equal to the height of the plant after D number of days. So we're going to relate the plant height is the height, the initial height plus the daily growth. Initial height plus the amount of daily growth. Initial height in one case here was 6 centimeters, and the daily growth is 4 per day. Okay, the other one is 10 centimeters and 2 per day. So right, plant A is H of D is D times the number 4 times the number of days. It's 4 centimeters per day, plus the original 6 inches or 6 centimeters that we started with. B is 2 centimeters for each day, plus the 10 centimeters that it started with. Okay, so you go ahead and graph them. And when we graph them, what are we going to get? We're going to get our y-intercept is what? The y-intercept on 1 is 6. Here's the y-intercept right there on the 1. And the y-intercept is 10 on the second plant. Okay. So, and the slope for the first plant, the one starting at 6 down here, I'm going to change this to, maybe I'll change these to red because it's the red line, right? And I'll change this and make this red right there. So the slope is 4. So our slope is, in this case, 4, a rise of 4, and a run to the right of 1. So if we start at 6 and we go 1, 2, 3, 4, and we run, oh, now, and the run is 4 over 1, 1, oh, this is, I'm sorry, 1, 2, 3, 4, right there to 10, and 1. Then we're going to go over 1 and up 1, 2, 3, 4. This is, each mark is 2 days, but it's the number of days is, the height isn't 2 centimeters per mark, and the days is 1 day per mark or per segment, right? So this is up 2 over 1, up 2 over 1. So here's where it crosses the other line. Now let's look at the blue. Changing to blue. So now we're going to say that we start at 10 and we go up 2 and over 1. Up 2 over 1. Oh, am I on the wrong one? The slope is 2. 1, 2 over 1. Up 2. Here we go. Same problem. Here we go. Same intersect. 2 comma 14. Okay. So the lines intersect at 2 comma 14. And therefore, after 2 days, both plants will be how long? How tall? They'll both be 14 centimeters tall after 2 days. Okay, example 2, check your understanding. You are testing 2 fertilizers on bamboo plants C and D. Plant C is 5 centimeters tall and growing at a rate of 2 centimeters per day. Plant D is 11 centimeters tall and growing at a rate of 1 centimeter per day. How many days will both will both bamboo plants be in how many days or after how many days will they be the same height? And what will the height be? So let's give it a try. Um, oh, this is your trick your understanding. Go ahead, pause it, try it yourself, and then when you come back, um, we'll do it together. Okay, I'm assuming you've tried it. You might have had some difficulty in trying to find a graph to get all these, because would be a pretty big graph by the time you're done. But I'll show you a little trick here to maybe make it a little easier to after you see the problem we're having here. So let's read it. Bamboo plants C and D. C, plant C. In fact, I'm going to change that to red right off the bat. Let me get rid of that. Go back to red. So plant C, okay, is equal to what? It's equal to 5 centimeters tall, 5 cm tall, and 2 cm per day. And plant D, I'm going to change that too. I'll go to blue for plant D. So plant D is equal to 11 centimeters tall and is growing at 1 centimeter per day. So plant is D is larger, but it's growing slower. So plant C can catch it. And everything you need to know here too is that it's growing. So everything's going positive. It's going to the right positive. It's going to the left, going up positive. So our slopes will both be pointing upward. And you're starting off with your blue line here at 11 centimeters. So maybe what I'm going to show you here is we had to draw the graph especially so that you don't have to have all these hash marks up to 11. So let's do it this way. Let's draw a line down here, and then I'm going to put a break in the line, and then I'm going to draw it down a little further. And then this one I'm going to draw, I'll draw across here. And I'm going to do this. I'm going to put a little squiggy line right there, right? So what that's kind of implying is that there's some number of data. You start at 0, 1, then there's some numbers, and we're going to pick up and start at a new number. Okay, so the first one we're going to get is 5 centimeters. So we're going to start here at 4 and 5. Okay, and then we have to go to 11. So 6, 7, 8, 9, 10, 11. Okay, the problem here is we had to start at this 5. 12, 13, 14. We're going to see how far that goes, right? So, and we're going to do 1 per day and 2 per day. So let's start with the red line. The red line says that our y-intercept is at 5 right here. I said this is, let's call this 5. Here's 5. That's 5. And our blue line is going to be 11. 6, 7, 8, 9, 10, 11. Here's our blue line, going to start there. Now our slope is 2 centimeters positive for the blue line, for the red line. So we're going to, 2 positive means what? It means 2 over 1. So for the red line, we're going to go up 2, and I got to draw them out here now. Wait, let me get gold. 1, 2, 3, 4, 5, 6, 7, 8. So let's try this. We're going to go up to 1, 2 over 1. Up to over 1, right? So let's see if that draws out. And it's going to go longer. I don't know where, I might have to readjust the line, but you'll see when we get there. And then 11 is up 1 over 1. Because it's 1, up 1 over 1. So that's the blue one. So we're going to go up 1 over 1, up 1 over 1. That's 2. Up 1 over 1. Here's 3. Up 1 over 4. 1, 2, 3, 4. There's 4 right there. Sorry. Then we got to go up again and up again. So it's getting way high. This one. And then up 1, 1, 2, 3, 4, 5, 6, over 1. These are getting hard to draw. Anyway, so it should be something like that. And I think this red line should have went, well, like that. The bottom line is they're going to intersect way out here. This is very hard to draw. So what does it say? It says that when this is 11, 12, 13, 14, 15, 16, 17. This is the height, and I reached it. And if that's the case, I would have 17, the height, and that's why I'm saying they crossed. I can't erase that, by the way. It'll erase the whole line. And it went out 1, 2, 3, 4, 5, 6 days. So here it is like here and here. So what we're saying is that it's what? 6 comma 17. Now, if you put in 6 comma 17 in both of these, what do you get? So let's try the red one. If I say 17 is equal to 5 times 6 plus, not 5 times 6, excuse me, 2 times 6 is equal to 2 centimeters right here, 2 times 6 plus 5. This is 12, right? And 5 is 17. And if I do D, we have 17 equals slope of 1x plus 11. And if when x is, so 17 and x, sorry, x is supposed to be 6 here. And 17 is equal to 6 plus 11 is equal to 17. These are true. It's kind of hard to draw that freehand. Hopefully yours came out better with your ruler. But just imagine we started down, we drew a straight line up, over, up to, over 1, up to, over 1, all the way up. That's a long line to draw. Better if you have graph paper, because then you can just count out the points and blot them. My points don't come out that smooth. Okay? Sorry for the little mishap on the X on the red line. Okay, objective 2, analyzing special types of systems. When two lines are parallel, there are no points of intersection. So a system of linear equations has, the system that we're talking about, has no solution because they never touch. They have to cross to have a solution when the graphs equations are parallel. Okay, example 3, systems with no solutions. Solve by graphing. Y equals negative 2x plus 1, and y equals negative 2x minus 1. So what do we see here? Graph both equations on the same coordinate plane. Well, we see the slopes are about the same. The things that are different are the y-intercepts. So when we graph it here, when we write it out, we have negative 2x plus 1. The slope is negative 2. The y-intercept's plus 1. And on the second one, we have negative 2 is the slope, same slope, and negative 1. When the slopes are identical, that means the lines are parallel. Look at these lines here. These lines here are parallel. The only difference is, let's do blue on this, a light blue, is where they cross the y-axis. Okay? Lines are parallel. There is no solution. They do not cross. So you look for the same slope. If they have the same slope, you know they're parallel. And then if the y-intercept is the same, then there's an infinite number of solutions, if you recall that from before. Okay, good. Okay, example 3, check your understanding. This doesn't want you to think about this. Go ahead and pause and think about it. And how would you answer that? They don't want you to, it says without graphing. So it's just basically talk about the lines. I'll give you time, come on back and we'll talk about it ourselves. Okay, so what do you think? It says, without graphing, how can you tell if a system has no solution? Well, remember we talked about it. We said if the lines are parallel, if parallel, there's no solution. Okay, if parallel, there's no solution. How do you know if they're parallel? If y equals some value times x, and or on the other equation, y equals some value times x plus or minus whatever, a question mark. If these are the same value, this -2 on each or +3 or whatever, if they're the same, the lines are parallel. They're parallel if the y-intercept is different. In this case, so this would have to be a negative. I'll erase this and call this one -2. So y equals some value that's the same as this other value times x plus some question mark that's positive versus or 2 negative, then those are parallel lines and they will never intersect, and so there is no solution. The y-intercepts have to not be the same. Okay? I'll draw it again. I'll say y is equal to 3x plus 1 and y equals 3x minus 4. The slopes are the same. The y-intercepts are different. They are parallel lines. Okay? Good. A system of linear equations has infinitely many solutions when the graphs of the equations are over the same line. The coordinates of the point on the common line are all solutions of the system, solved by graphing. Okay, so we say here that 2x plus 4y equals 8. Now, something you should know, and you probably could remember, 2x plus 4y equals 8 is the standard form of the line, right? It's a standard form equation of a line. Wonderful for determining the y-intercepts. And you'll see it, we'll talk about it here in a minute. The other form, y equals -1/2 x plus 2, is the slope-intercept form of the line. And that's good for determining the slope and also where it intersects the y-axis. So it says graph both equations. We have two equations there on the same coordinate plane. The 2x plus 4y equals 8. And the y-intercept is 2 and the x-intercept is 4. And you see it. I'm going to change the color here to, let's say, red. So you see it right here. The x-intercept is 4 and the y-intercept is 2. How do you know? If you take and you set x equal to 0, that gets rid of the 2, and then you solve for y, you're going to divide both sides by 4 to get the y by itself. You're going to have y is equal to 2. But since you zeroed out the x, that's when you're solving for, you're looking for y, right? You zeroed out x, so now you have your y value. Now you zero out y, and you're going to get negative for the 4y, not a negative, 0 for the 4y. So you're going to get 2x equals 8. To get the x by itself, you're going to divide both sides by 2, and you're going to get 4. So there is your x-intercept. X equals 4. So now you have that. So now y equals -1/2 x plus 2. So now we're at the plus 2 for the, I'm going to go to a blue line now. So now we have a plus 2 for the y-intercept of the blue equation, right? And now we need the slope. What is the slope? The slope says it's a -1/2. Well, let's look at this. If a negative, this is 1, 2, 3, 4, and we got a negative, right? So if we go -1/2 is 1, is -1 down and 1, 2 to the right. 1 down and 1, 2 to the right. Okay? The slope is -1/2 and the y-intercept is 2. And you see that the dots are the same. So the graphs are the same line. Solutions are an infinite number of ordered pairs x, y such that y equals negative 1/2 x plus 2. So as you see, any dot along this line, any one you pick, how about this one here? That would be a solution to the equation, to the system. That would be the solution. They're all applicable. Every point, okay, is a solution. So there's an infinite number of solutions. Okay, check your understanding. Example 4. Solve by graphing. So we have our two equations, y 1/5 x plus 9 and 5y equals x plus 45. So first of all, let's go ahead and get these in a form that make it easy to graph. So we want to get the y by itself on the second equation, and I'm going to call that second equation the blue equation. So the blue equation is going to be equal to what? I say we're going to divide both sides by 5. Okay. So what am I going to get? We're going to get y is equal to 1/5 x plus 9. Right off the bat. You see what we have? 1/5 x plus 9. It's the same equation. We've already solved it. But if you're going to graph it, what would you have to do? To graph this, it's I guess you could put, well, I guess you could take and put in this is in kind of in standard form, they're assuming. So what if we redid this, leaving this one in slope intercept form? We have our graph, and we have 9 is our, so 5, 10, 15, 20. 9 is going to be right about here. And then we're going to have 1/5, so that's going to go up 1 over 5. So each one of these is 5. So if we go, and 1 is very tiny, right? So if we go up 1 over 5, up 1 over 5, very low slope, up 1 over 5. It's going to be a way low slope, something like that, right? Then the other equation is going to be, we're going to try to get the y-intercepts and see the x and y-intercept. So if I rewrite this to 5y minus x is equal to 45, what am I going to do here? I'm going to say that if I zero y, I'm going to get negative x equals 45. Well, then x is equal to negative 45. Can I say next x equal to negative 45? That's going to put way over here. Well, could be way out here. 5, 10, 15, 20, 25, 30, right? 35, 40, 45. Obviously, my line missed, and it probably I did miss. So it's probably right out here, right? So I have that. That's the x. And then I have, if I add by 0x, I get y. 5y is equal to 45. I get y equals 9. So I get the y-intercept of 9. I get it right here. And if I 0x, I get 9. If I 0y, I get negative. So here's the 2 points. And if you look at them, they do. The lines are kind of coincident, or they do coincide, don't they? It's hard to draw that for me without a ruler. Sorry. But here's the 9 and here's the negative 45 way out here. And they do go. So in this case here, the 1/5 x starting at 9, and you do the 1/5 up. So I did a little up here, up 1 over 5, up 1 over 5, and it made this go way out here like this. Hopefully you see that. That's very complex to see. Maybe I can draw it again. Why don't I try and, we're in no hurry here. I'm going to go back. hit the, get rid of the lines. Oh, why I want it, there it goes. The blue one's gone, that little blue line's gone. That blue line's gone there. Blue line's gone. Blue's gone. Blue's gone. Okay, let's see if we can go with this. This is gold. I'm using gold right here. So if I said 5, 10, 15, 20, 25, 30, 35, 40, 45 right here, right? 45. That's center. I'm going to put a dot there because we're going to get to it anyways. And I'm going to solve the standard form equation right now. So I'm going to say if x is 0, y is equal to 9. 45 divided by 5 is 9. And here's where we came up with our 9. Blue, 9 is right in here. Okay. And then if y is 0, x is equal to negative 45 because negative x is equal to 45, x equals negative 45. So here's our negative 45 way down here. And there's our line. And remember, I was drawing them. That's the other equation, the gold one. So it's the slope is kind of odd to draw for me. It's something like that. That's not too bad. I'll leave. I won't do any more on the blue line. So now I'm going to go to this one up here. I'm going to call it the red line. Now it's telling me that y is equal to 1/5 x. So 9, I'm up at the 9, same point. Except now I'm going to go up 1 and to the right 5. Up 1 and right 5. Up 1 to the right 5. Up 1 to the right. So let's assume that that's it. So if I did that, I'd draw basically, guess what? The same line. And so there's an infinite number of solutions here with these two equations because these lines are right on top of each other. The y-intercept is exactly the same for both, and the slope is the same. 9 divided by 45 is 1 divided by 5. Okay? Hope that works out for you. Sorry about that trouble, but maybe it's a little clearer now that we redid it. Okay. And then finally, analyzing the special types of systems. The number of solutions of a system of linear equations, different slopes, right? So you see two different slopes. The red line and the blue line, they intersect right here, one time. The lines intersect, so there is one solution, and that cross is called the solution. If you put that point into both equations, whatever they are, you'll get the same answer. How about the slope of different intercepts? If the slopes are the same and the intercept is different, here's one intercept and here's the other one, then they're parallel lines. And if the slope's the same, there's a red and a blue hiding in there, and there's only one y-intercept, okay, there is no solution. No solutions. Or no, excuse me, many solutions. No defined solution is what I meant to say. Many solutions, okay? Good.